Okay, next we're going to talk about how to compile basic C programs using GCC, and then we'll move on to using makefiles. And so, as you can see, we're in the subdirectory labeled first under ECS36B. We can go ahead and print that working directory just to verify that. You see that reflected there on the screen. Next, I'm going to go ahead and print the contents of the directory that we're in. So we can see that we have some C file, firstprogram.c, there in the directory. Let's go ahead and take a look at that, see what it looks like. So we can see it's pretty basic. Looks like it's going to take, you're going to enter a number, it's going to find the absolute value of the number and then return it. So we'll go ahead and compile that using GCC. So very, very basic is just use the GCC command. If it comes back with the command not found, you have to go ahead and install it in your environment. So if you're on macOS, I recommend using Homebrew. If you're on WSL or some version of Linux, then it's probably going to be a apt-get or well, it depends on your package manager, Yum, etc. But use the appropriate package manager to go ahead and install GCC if you don't have it. So go ahead, you type GCC, and then the input file that we're going to be using to compile from, and then you can go ahead and specify an output name using the -o output flag. And in this case, let's just call it first prog, and we'll go ahead and hit enter. Great, we didn't get an error, we didn't get any feedback. That's good. That means the command ran successfully. We'll go ahead and do an ls just to confirm that there is now an output file called first prog, and there it is. So now let's go ahead and run it. And the way we do that is we do a dot and then / and then the file name, and that's going to go ahead and execute that. So just as expected, we need to enter a number, so let's go ahead and test it out. Let's give it a -9. We expect that it should return 9, +9, and there you go, it does. So that is the absolute basic of how to compile a program, a C program, on the command line using GCC. So moving on, a little more complex. We'll go to the next. Okay, so here we are in the second directory. Let's go ahead, take a look at what we have working with. We have a few different files here, obviously a little more complex. For this, we're going to be using a make file to do the compilation for us. Now, make is another utility that's present on most Linux or Unix systems. So you should have that on macOS as well as WSL or any Linux distros. If you don't, once again, use the appropriate package manager to install make. And oh, at any time, if you're ever curious about a command, you want to know how to properly format it, what sort of input it takes, what kind of outputs you should expect, maybe any additional information or parameters necessary, or maybe flags that you can feed it, you can always type man and then the command name. So let's go ahead and look at that for make. So man, by the way, is just short for manual. So it shows you the manual page for make. And so as you can see here, it gives us the name, a very brief sort of overview of how the command should look when you type it. So that's under synopsis there. Description gives you a more long form narrative of what make does, how it should be used. And then below that we have options, which give us all the various flags and how those flags should be formatted in order to elicit different responses from the command. So always remember that you have make, or excuse me, you have man to fall back on in order to understand Linux or Unix commands. So let's take a look at the program that we're going to be compiling. So we can just go ahead and print that to screen using cat or concatenate to screen buffer. What was that called again? Let's see here. So main.c. So this is a C program that's going to print the number of days in a month. You can see it there. Pretty straightforward. So let's go ahead and look at the make file and what that consists of. So this here is much more complex of a make file than what you'll need to typically use, or even what you'll start off using at least. In terms of complexity of make files, this actually is not that complex. It just looks like a lot if you don't know what you're looking at. But most of it is actually comments. So you see all the lines that start with the octothorpe or pound sign or hashtag if you prefer, but the actual name of the character is an octothorpe. But all of those lines are comments, and so you don't actually need them there, but they do help the human behind the keyboard understand what's going on. So if you have to pass it off to someone else, it's always nice to have comments so they can understand what your logic or reasoning was behind a particular decision. Please comment your code. I mean, it's even to help yourself. You know, you put down some code, you come back to it, you know, a week later, 2 weeks later, a year later, and you have no idea why you wrote something or why you configured a data structure a particular way, or so just always be commenting. But anyhow, so I'm not going to explain all of the elements of this right now. Just understand that this is what a makefile looks like, and then I will show you a much simpler one that I will explain. You will not need to use as complex of this one initially, but if needed, we will build complexity on the more simplified version of the makefile. So, but let's go ahead and utilize make to generate our executable. So we're going to go ahead and just type make, and make is going to automatically look for a make file. Once again, you can see that there, which is called make file. So if we run make, it ran the GCC command in the background. Essentially, it looked for the main.c. It also used the main.o as an include, and then the output is the month_calc output, and that's going to be our executable. And so let's go ahead and execute that and see what we have. So great. We can enter a month number, so let's go ahead and enter 6 for June, and it tells us that we have 30 days in this month. Great, excellent. It does what we expect it to do. So let's go ahead and take a look at the next example. So here we are in the third directory. Once again, we'll confirm that. And let's go ahead and see what we're working with. So we can see that we have a few files in here already. Actually, I compiled it earlier, so let's go ahead and remove that so I can start from scratch and show you all how this works. So let's take a look at the program that we have here first. And so you can see here we have a program. It does just some very basic pointer math. It takes two integers and adds them using pointer operations. So we're going to go ahead exit out of there. And then let's take a look at the make file. This is a very, very simple version of the make file. Here, I'll open it in Vim so it's a consistent presentation here. So you can see there's two lines. One is the target, which in this case is going to be the third program.c file, and then the command that's going to run on that, which is the GCC command. And this time we're going to feed it some flags. So we are feeding it the .g, which inserts flags for debugging, so we can use that with GDB. I'll be demonstrating that in the next video, and just kind of running through the basics of debugging. And then the next flag here is the WALL command, which basically will generate all warnings that the compiler has for this program as it compiles. Normally those are suppressed, or at least by default those are suppressed. And so we're going to take the third _program.c as input, and we're going to generate an output named tprog. We could go ahead and name that whatever we want. So here, let's go ahead and change that to, I don't know, how about third exe. We'll go ahead, we'll exit out, we will save that via Vim there. And then let's go ahead, clean our screen there, and run make. You can see what ran in the background with make is that GCC command with those flags and the parameters that we specified in our make file. It's a lot easier than having to type that every time you want to compile it, especially if you're, neck deep in a programming assignment and you're having to try and compile it over and over. Maybe it's not cooperating, you end up compiling it 50 times, and it gets pretty annoying having to type all those flags on it every single time instead of just typing out make. So let's go ahead and execute the output from that. So the program runs as expected. We'll go ahead and enter a couple integers here. And there you go. It added the two integers using pointer math. So we can see that worked correctly. So like I said, in the next tutorial, I'm going to go ahead and just run through the basics of using GDB for debugging. Thanks.